Welcome to the Lockheed Martin and General Motors announcement about lunar mobility. I'm Leland Melvin, joining you from Virginia. And as a former NASA astronaut, I'm very excited to be a part of this major announcement. As you have likely heard, early this morning, there was a cool celestial event, a lunar eclipse. It was also a supermoon, which means the moon is closer to the Earth and larger than normal. So having both of these lunar events happening on the same day as our lunar mobility announcement is very apropos because of NASA's Artemis program. We are closer to returning to the moon than we have been for the past 50 years. So on this lunar day, we'll begin with an exciting announcement from the CEO of Lockheed Martin, Jim Taiclet, and the CEO of GM, Mary Barra. Then we'll take some time to discuss that announcement in depth with some senior leaders from Lockheed Martin and GM. And we'll end with a live reporter Q&A, so get your questions ready. You can submit them using the Q&A icon at the bottom of your screen anytime during the show. This is going to be a really fun discussion, so let's get started.
Hello, I'm Jim Taiclet, CEO of Lockheed Martin.
Hello, I'm Mary Barra, Chair and CEO of General Motors. And we have an exciting announcement.
Lockheed Martin and General Motors are teaming up. Together, we are going to develop the next generation of lunar rovers.
NASA will need rovers as part of its Artemis program, which will return astronauts to the moon.
Our alliance will draw on our strong legacies of engineering performance and reliability, and we're confident that it will lead to transformative vehicles with unmatched capabilities and technologies we can use right here on Earth.
Our next generation rovers will help NASA astronauts safely go farther and faster as they perform high priority science on the lunar surface.
These rovers will also have autonomous capabilities, enabling them to operate even when humans are not present.
At GM, we are all in on electric vehicles, and this opportunity is just another way that we are shaping the future. I'm especially happy to be embarking on this journey with Jim and Lockheed Martin, as we seek to take our alliance to the moon and beyond.
You're right, Mary. These next generation rovers are just the beginning. We look forward to working with GM to build a better tomorrow. And our first step will be to proudly support NASA and the Artemis program as they inspire us, unite us, and advance the frontiers of science by taking our nation back to the moon and onto Mars.
Wow, that's really exciting news. We have a great lineup of executives from Lockheed Martin and GM to talk about this cool effort. So let me start off by making some introductions. Let me first introduce you to Lisa Callahan from Lockheed Martin, who is the Vice President and General Manager for Commercial Civil Space. Hi, Lisa.
Hey, Leland, how are you?
I'm great. And also joining us is Alan Wexler, the Senior Vice President for Innovation and Growth at GM. Hi, Alan.
Hey, Leland. Thanks for having me today.
Oh, great that you're here. And Kirk Sharman is the Vice President of Lunar Exploration Campaigns at Lockheed Martin. Hi, Kirk.
Good morning, Leland. Great to see you.
You too. And Jeff Ryder is the Vice President of Growth and Strategy at GM Defense. Hi, Jeff.
Hey, Leland. Happy to see you.
You too. You too. All right. Well, let's get started. Thank you all for joining to us today. And that was a huge announcement that Jim and Mary just made. Now, let's talk about the rovers and the two companies coming together. Got a few questions for all of you. So I'm going to start it off with Lisa. Now, can you talk about why this alliance with GM is significant and what drew the two companies together?
Yeah, Leland, when I think about the Artemis program, we're going to take humans back to the moon, something we haven't done in almost 50 years. And that is so exciting in general. And in order to have a sustained presence at the moon, we're going to need mobility. It's going to be a critical piece of that infrastructure. And it's also going to take aerospace companies and non-aerospace companies working together to build that infrastructure. And for mobility, I could think of no better partner than the number one US auto manufacturer in GM. And GM is making billions of dollars in investments in battery technology and autonomy. And we're really excited about this partnership, and pairing that with our expertise in building deep space robotic and human spacecraft. We have a team that I really think can help not only the Artemis program, but that whole lunar infrastructure. So we're really excited about being partnered with GM.
That's exciting. I mean, it takes the most diverse groups to come together to make the best solutions. And I think that's what's happening with Lockheed and GM. Hey,
Absolutely.
Alan, from GM's perspective, what synergies did GM see in teaming up?
Well, I'll follow on Lisa's lead. So thank you, Lisa, for the gracious statement. But just like GM is #1 in our space, Lockheed Martin is #1 in the human space rated space, if you will, and human race rated company on Earth. But with the safety being one of the most important factors for going to the moon again, this was really an easy decision for us. And furthermore, we were immediately impressed with the open and collaborative dialogue that we have with each other that really was the formation of our initial relationship when we came together.
And is this the first major teaming between the two companies? If so, why does it make sense now? If not, provide some history of working together.
Well, great question, Leland. This is the first alliance we've made with Lockheed for this type of work. The alliance makes sense now because of the incredible opportunity that we have to combine the robust expertise of both of our companies to accomplish the mobility goals of the Artemis mission. I mean, this exciting project gives us a phenomenal reason to come together and help advance the next era of lunar exploration and to bring those learnings back to Earth.
Exactly. Now, Lisa, tell us about Lockheed Martin's work with NASA and their Artemis program.
Yeah, so Lockheed Martin's been working with NASA to take humans back to the moon before the program was even called Artemis. And we're really excited. The development of Orion, the spacecraft that's going to fly humans to the moon, is part of what we've been doing with NASA for a number of years. That spacecraft has flown before, and it's getting ready to fly again at the end of this year. We're also leveraging technologies from Orion into human landing systems, habitats, and we'll leverage that in our mobility platforms as well.
Look, I've got my flight suit on. I'm ready to go. When you guys get ready, I'm ready to jump on.
We'll look to make sure you're not hiding away in Artemis 1 when we fly later this year.
I think there was a recent movie called Stowaway that was on where someone was left on a vehicle and went to space. But anyway, hey, Alan, back to you. Now, GM has a long legacy in space. Can you talk more about how the company has supported the space program over the decades?
Sure. First of all, sign of the times. I get to be on the moon in my Zoom background today. So it might be the closest I personally get for a number of years. But to answer your question, Leland, GM has a proven history of supporting NASA and working with the space industry for over 50 years. And we've manufactured, tested, and integrated the inertial guidance and navigation system for the entire Apollo moon program, including Apollo 11, which was the first manned landing in 1969. In July 1971, Apollo 15 astronauts explored the moon in the first electric-powered lunar rover. Thanks to the help from General Motors engineers, the moon's lack of atmosphere ruled out using internal combustion engines. The LRV, the lunar rover, was a textbook example of pushing the envelope of creativity to meet what we saw as an unprecedented customer requirement. It carried a payload of over 1,000 pounds. I think it was 1,080 to be exact. And that included the driver and the passenger, which was really more than twice of its own weight of the vehicle itself. So it also operated at temperatures nearly twice as hot as the Sahara and twice as cold as the Arctic. So you can imagine how challenging that was. In 2011, NASA, GM engineers, and scientists used leading edge control, sensor, and vision technologies to build what we were calling Robonaut 2. And Robonaut 2 is a dexterous humanoid robonaut. R2, as affectionately known, traveled to the International Space Station and became the first humanoid robot in space. And then lastly, 5 years later, the robotic glove technology developed from Robonaut 2 made its way into healthcare, manufacturing, and other industrial applications through a licensing agreement. So just like I said earlier, we look to leverage the technologies that might not be invented for the use on Earth and bring them back to actually help humankind.
That's such a storied legacy in space, and it's just great that these two companies are coming together to leverage that past history. And Kirk, we used to work together at NASA Johnson. I miss those days working together to do space missions. But you lead Lockheed Martin's lunar exploration efforts. How does this lunar mobility effort fit into the Artemis program? And why does NASA need lunar rovers in surface mobility?
Sure. First off, I'm looking forward to working with you again when we'll go drive this rover on the moon. So,
Ready.
I'll need a flight suit, but I'm ready. Lunar mobility is really huge. Think about it. In order to safely land the first woman and next man on the surface of the moon, you need a relatively flat place and no boulders. Unfortunately, the scientists like boulders and they like really unflat craters. That's what they want to look at. So you really need to take, how do you get the humans from this nice, smooth, flat place with no boulders over to the really scientifically interesting places? Not only themselves, but the equipment. And by the way, when they're there, they want to take some samples and bring them back. So mobility, rovers really fits into that. It really leverages the unique capabilities of humans to do more. And the same is true for experiments or other activities on the lunar surface. You can imagine a cargo lander, same story. You want it to survive the experience of landing on the moon, so you want a relatively flat spot, no boulders. But the scientifically interesting places might very well be in the shadow inside of a crater. How do you get those payloads, those experiments to those locations? Or how do you take a sample of lunar ice and bring it home? All that's going to require mobility. And that's why we're really excited to be teaming with GM and working on these rovers together.
That's fantastic. Now, you mentioned extending the range of exploration for science, but specifically, what science will be performed and how will that help us back here on Earth?
Sure. Now, I'm not a scientist, but I've had the privilege of working with a number of scientists over the years. The unique thing about the moon is its perspective. It has a very unique view of the world, of Earth, and really of our solar system. So from the moon, you can look back at the Earth and you can see how the charged particles from the solar wind interact with the Earth's magnetosphere. So you can see that from outside, whereas from the Earth, you're looking from a completely different perspective. You can actually use the moon as a shadow to block out electromagnetic radiation, basically noise from the Earth and from the humans, to do radio astronomy. So it's a great place, probably a unique place close to Earth to do those types of activities. And finally, we believe that there's large stores of lunar ice and either other volatiles on the moon in craters that are shadowed from the moon. So you can actually go and explore those. And that ice really is the key to unlocking further exploration by humans and even robots. And then finally, the South Polar Aitken Basin is a really unique place in our local region of the solar system. It's very, very old. It has the oldest impact craters around. And since there's no wind or water, it hasn't eroded. So scientists can go look at this and understand not only how the moon was formed, but really understand how the Earth and some of the inner planets were formed. So a great scientific bounty here on the moon, and that's just scratching the surface. And that's why I'm so excited to be part of this program.
Kirk, you're sounding like a scientist every minute of this conversation. Hey, now, Jeff, I want to ask you about Jim and Mary showed a concept of the lunar rover in their announcement. Now, let's bring up the animation concept and have you introduce it.
Sure. Thanks, Leland.
So please describe the video to us and why it's an early concept and not just a finished design.
Sure. So first of all, I think there's a wow factor to it, right? We're all excited. And, for folks at GM, if you're a vehicle engineer and you have the opportunity to work on the lunar vehicle, this is pretty much a dream come true. So, our teams are working this real time. And part of the purpose of the video is to share that excitement with a much broader audience. So while this is very much an early stage representation of what we think the application might look like, that excitement is something we want to make sure we're sharing with as many people as possible, because we're certainly feeling it here. To pick up on Kirk's comments, what you see here is, lots of potential applications. When you see, numerous headlights in the background there, that's inferring that we're likely to see more than one vehicle, perhaps, right? There's a lot of different missions that astronauts are going to have to perform, and there are going to be times where the astronauts will be teleoperating, or the vehicle will be operating autonomously. So whether it's traversing the lunar surface or conducting science missions, logistics operations in support of the habitat and the permanent, the facilities, we see lots of different applications for mobility, and it's what makes the mobility part of the Artemis program so important. It's such an exciting opportunity for us. Just in terms of where we are in the process, until we see the details of the request for proposal, these are really just a glimpse of how we see the opportunity playing out and what that operation might look like. But as we get closer into the RFP stage of this, we'll be able to offer a lot more details.
Wow, I'm really excited. Kirk, do you have anything else to add to that? I'm
Sure.
I'm getting really pumped up right now.
Yeah, me too. The farthest that humans traveled from the lunar lander in on Apollo 15, 16, and 17, the farthest they went was 5 kilometers. Now, if you're a runner, 5 kilometers is 3.2 miles. I used to be able to run that far. So 3.2 miles. The moon, the diameter of the moon, the circumference, I'm sorry, if you were going to drive around the moon or fly around the moon, 6,800 miles. So can you imagine the farthest we've ever explored is 3.2 miles right around where we landed. So mobility is really going to open up the moon for us. It's really going to open up for humans to explore. It's going to open up for scientists and for other commercial activities. So I'm really excited. Just like Jeff says, where this goes is really exciting. I think there's huge potential, and like I said, we're really happy to be teaming with the General Motors on this endeavor.
That's fantastic. Alan, you lead the innovation and growth for GM. How does this effort fit in with GM's 000 vision and larger electric vehicle initiative and the overall growth strategy?
That's a great question, Leland. Our vision for zero crashes, zero emissions, and zero congestion is really about creating a safer and better world for all of us. It's an ambitious goal for us that requires a significant amount of investment and innovation. And to be clear, our scope of impact here goes well beyond the walls of GM. And in this case, it actually goes beyond the planet we live on. Through the alliance that we're establishing here, we have an amazing opportunity to leverage our insights in electric vehicles and autonomous capabilities as well, along with other proven commercial technologies that we've developed for Earth, and we think we can apply them for mobility platforms that are quite literally out of this world. And the potential for what we're producing with Lockheed will help drive science, innovation, and technology forward exponentially, we believe, for all of humankind. I mean, how could we pass up this opportunity? You watched that video, you've been on the space shuttle. It's just it's a once in a lifetime opportunity for us. And I would just reiterate what Jeff said, there's no shortage of people within General Motors who want to work on this program.
Yeah, no, when we explore together, we find out new things that we bring back to our home planet and take care of the people on the planet. Now, so Jeff, can you talk about the potential of us using advanced battery technology for lunar applications?
Sure. Well, it's one of these questions like, why do we go to space, right? And ultimately, it's to improve the human experience and sort of, extend those outer boundaries. But it all comes back to Earth, right? I mean, what we do through this program, the opportunity that we have to leverage our, tremendous battery electric know-how, our technology base, our engineers, we anticipate that learning being applicable to our commercial roadmap, as well as a lot of adjacent market and new growth areas that Alan referenced. I would just point to the challenge of operating in space and some of the earlier comments about these extreme thermal environments, right? Extreme temperatures, long nights that last up to 14 days. These are the kind of engineering, and science challenges that through this program, we have the opportunity to demonstrate our tremendous capability, our commitment to electrification for vehicles and as well as in other applications, and learn through this program to take that back to our core roadmap and continue to look for, applications where the performance and the safety of this program and what that offers us can be, brought into numerous applications. So it's really a great opportunity to work with NASA and work with our customers in that area, and then bring it back to the folks here on Earth.
Yeah, I think you mentioned this, but the development work on these vehicles does influence and help, I guess, the company's electric vehicle work back here on Earth. It's a win-win for all of us, right?
Absolutely.
Yeah. Lisa, I think the necklace you have, it looks like it came from another planet, but I think Kirk mentioned that everything has come from somewhere else. So now, are there technologies that you developed for Orion or other space exploration missions that can be applied to this effort too?
Leland, absolutely. The amazing women and men that we have in our workforce are really going to leverage their expertise and experience in building human and robotic spacecraft and bring some of those technologies right onto this mobility program that we're talking about. On the human side, we do a lot in technology development for the crew interface to systems, and we'll leverage that type of technology and capability, as well as reliability to assure the safety of the crew. On the robotic side, we have autonomy in our robotic spacecraft, as well as robotic arms and other things. And I think a great example, recent example to share is when OSIRIS-REx visited Bennu recently and took a sample. We'll be using technologies like the natural feature tracking that was a part of OSIRIS-REx to determine where and how to tag the asteroid safely. And then that robotic arm with the tag SAM head on the bottom will be how we'll be leveraging robotics to explore the moon and to collect science as well. So yeah, we will absolutely have lots of applications for the technologies that we use in our human and robotic spacecraft.
Fantastic. Now, Jeff, can you talk more about GM's investments in autonomy? And are there opportunities to explore uses of those investments in support of this effort?
Yeah, absolutely. To pick up on Alan's comment about the 000 strategy that GM is committed to, we're investing over $27 billion through 2025 in our electric vehicle, autonomous vehicle portfolio. And that's that corporate commitment to the future that we see in, related to 000. We're going to leverage those capabilities in the, let's call it the extreme off-road environment on the moon. So I would say at this point, what we have is a tremendous toolkit, a commercial autonomy baseline that we can work from, and we're heads down right now and investigating how we would take those capabilities and apply them to the specific missions and operations associated with the Artemis program.
27 billion, that's a significant investment in that technology. It's a really great commitment. Kirk, Lockheed Martin has also extensive expertise in spacecraft autonomy. Can you explain how this will work with GM's capabilities and the rovers?
Sure. Well, Lockheed Martin has 50 years experience in deep space robotic exploration. In fact, we're the largest private company to do those kinds of things in the world. In fact, we outperform most countries on the planet in that experience. We have great experience in the space environments and in integrating and building spacecraft. From autonomy, of course, our spacecraft, these deep space probes are all autonomous. So that's what we do. Lisa talked about OSIRIS-REx here that recently, last year, performed flawlessly in capturing a sample from Bennu. So that's in our wheelhouse. Of course, GM is investing heavily in autonomy from an automotive perspective. So they have the understanding of four vehicles or four tires on a terrain. And the off-road environment. So putting those sensors, those software, all those technologies together make perfect sense. It's really a perfect marriage for autonomy on a foreign body like the moon. And kind of pulling on what Alan said, safety, zero crashes is really, really important. So that autonomy can help us in multiple ways. Obviously, one is safety, right? The autonomy feature of a vehicle can keep the crew members from actually doing something that wouldn't be safe for them. So waiting for an ambulance on the moon is going to be a long wait. So we really need zero crashes on the moon. That autonomy can help leverage what a crew's accomplishing on the surface of the moon. You can imagine the first woman on the moon needing a bunch of tools and wanting to bring samples back. What a great place to use the autonomy of a rover following her along as she's taking these samples. And so all those things really pile together. And when the crew's not there, you have the ability to actually go and move sensors and equipment to other places while the crew's not present. So really leverages the investment that the United States and other countries are making to have these rovers on the lunar surface. So we're really excited about having this autonomy capability and about joining the great experience and investment of General Motors together with the experience and investment of Lockheed Martin.
It's a perfect synergy with all of these, systems that have been developed for different reasons, but now they're coming together for exploration in a really big way. That's perfect. Now, NASA calls this the Artemis generation. I feel like I'm part of the Artemis generation, even though I'm a little bit older. But Alan, with GM's Everybody In, is there a synergy between an all-electric generation and the Artemis generation?
Sure. And before I answer that, I have to say, Kirk, every time I listen to you talk, I just get more excited about our partnership and the impact from what we're doing together. So we're super lucky to be part of this generation. Leland, I view the all-electric generation and the Artemis generation sharing this desire to connect with a purpose that is really larger than ourselves. To put technology to work in service of helping the greater good of humankind, and to be open to a new way of living, frankly, day to day. And I also believe through our partnership with Lockheed Martin, we're going to push the boundaries here of what's possible. And we'll use these new and proven technologies to advance the way we work, and more importantly, the way we live.
That's fantastic, Alan. I really appreciate that comment. Lisa, what are your thoughts about the Artemis generation and how this mobility effort ties in?
Oh, Leland, the Artemis generation is really exciting for me for a number of reasons. We're going to put the first female and the person of color on the moon for the first time. And that in itself is pure joy for me and excitement. But on top of that, in my career, I worked with folks that have been a part of what I would call the Apollo generation, and it inspired them to get into this business and to build spacecraft or to be astronauts like yourself. And what I'm looking forward to is having women and girls see themselves as a part of this Artemis generation and want to be an astronaut in the future or be an engineer or scientist that's building this. It's my vision that 2 women in a rover on the moon becomes the iconic picture of what the Artemis generation is. And I can't wait.
Oh, that's awesome.
But Leland, I want to turn the tables and ask you a question.
Okay.
We're talking about the Artemis generation and how it can inspire this generation. As an astronaut, tell me what you think about the Artemis generation. And I want to know, will you ride in our rover?
Okay. Second question first. Yes. I'm ready to go right now. So once it's ready, just give me a call. I'll be right there, ready to go. But the first question, the Artemis generation to me is when I think about the Katherine Johnsons who helped John Glenn, helped us get to space safely and back home from the moon and from that first mission on Friendship 7. And I think of the moments when I went into classrooms to talk to students and I showed them the quote, "One small step for a man, one giant leap for mankind." And I asked the kids in the room, I said, "How many of you want to be astronauts?" And all the boys raised their hand. And I went over to the little girls and they said, "Well, you said it's for men. I'm not a man, I'm a woman." So this program, this Artemis generation is going to, I had to change from one small step for a man to one giant leap for, I said one small step for a human, one giant leap for humankind. Until then the girls raised their hands. But seeing these role models, these examples like Katherine Johnson and Peggy Whitson, who was my commander on the International Space Station, first woman on the space station. And now we're going to have the first woman on the moon and little girls raising their hand saying, "I'm going to beat you out, little boy, because I'm going to be the first one on the moon or next person on Mars or whatever." So it's just really important that we show that this is for everyone. And the most diverse teams give us the best solutions. And so I'm all in for Artemis generation.
Awesome. We're looking forward to it.
Now, Lisa, Alan, Kirk, and Jeff, thank you so much for this great conversation. This has been really exciting news, and I appreciate everything that you're doing to bring teams together to solve problems that we want to do. But we do have some time for reporter questions. So let's get to those. So we have a little bit more time. And as we bring everyone back together to answer your questions, just a reminder, you can submit questions in the Q&A icon at the bottom of your screen. So let's get started.
Leland, I have a question here. It's from Anonymous, but it says, has NASA awarded a contract to GM and Lockheed Martin for a lunar rover already? Or is this an announcement for the two companies to submit a proposal to NASA as a bid for the contract?
I'm going to turn that over to Lisa and Alan. You guys want to take that one?
Yeah, absolutely. As I said at the beginning, the Artemis program is to take humans back to the moon and to have a sustained presence on the moon. And we see that sustained presence, that a critical element of that is going to be mobility for a number of reasons that Kurt explained, as well as Jeff and Alan. And as we're looking towards the future, this partnership is really about getting ahead of NASA's future procurements that they may have, and really looking at the commercial environment that's going to be on the lunar surface, and building this partnership in advance of that so that we can lead the way in mobility on the moon.
That's a fantastic answer. Gary, you have any other questions?
We've got quite a few. This one is a little redundant, but it's got a second part. Maybe Jeff can take this one. When do you anticipate the RFP will be released for the LTV, but specifically, will this offering be based on an existing GM vehicle, or is it purpose-built?
Sure.
Want to get that, Jeff?
Sure. So we're anticipating seeing the RFP later this year, probably in the third to fourth quarter, into the fall. In terms of the technology, part of this is leveraging the commercial technology baseline that we have. So where we can, we want to bring proven performance, proven technology, but there's certainly going to be, a significant development effort associated with this, just given the nature of the program and the program's objectives, and the fact that, the country hasn't done this in a while. So this is a more ambitious vision for lunar habitation and mobility. Some of that we'll pull off the shelf, and the rest, as a team, we're going to figure out how to get it done.
Great. Fantastic. Gary, you say we have tons of questions out there, huh?
Tons. Question from Jillian. She goes, can you give any more details about the rover's range or other specifications you're aiming for?
Okay. Jeff?
I guess I could take that one, Leland.
Okay, go ahead.
Sure. So we're still in early formulation. So we know the kinds of things that we'd like to do and the kind of range. So I mentioned earlier in this event about the range that the previous rover had, and we would certainly want to have greater range. We'd like to be able to survive those extreme temperatures from minus 280 degrees Fahrenheit to 260 degrees on the positive side. That's even colder than a Texas winter. So we need to be able to survive those temperatures. So those are the basic capabilities. Obviously, we talked about autonomy. We want to be able to supply to service payloads. So there's lots of work to be done on defining the details of those interfaces and those capabilities. And we'll look forward to sharing those as we get further along in our development.
That autonomy piece is going to be really powerful for having a sidekick following you along as you're moving around, and then telling it to go off and do some more exploration. So that's going to be really, really exciting to see. Gary, what else do we have?
Kayla is asking, what role does GM Defense play in this? Where are you in the development process? Have you developed a proposal to NASA yet, or when do you plan to do so? So a question about GM Defense's role.
Sure, I can take that one, Leland.
Okay,
so
good.
GM Defense is GM Defense LLC is a subsidiary within General Motors. Our team is focused on purpose-built applications for government and military. So, certainly focused with Army and U.S. land systems, but NASA government customer rover, sort of fits into our wheelhouse. So. Think of GM as a family where we're at the front end on this one because it's a government opportunity. but we have reached back into the, the full scale and scope of GM, engineering, R&D, and the capabilities of the broader corporation. So this is very much a, a one team GM effort. In terms of the second part of your question about, the opportunity and where we are, it's really that later portion of the year where we would see an RFP that might help define this better. But to other points that have been made, we're already working on this. We're moving, through the process ourselves, in parallel with the NASA RFP program.
Great, Jeff.
Just one thing to add to that Jeff mentioned is, I think most people are probably familiar in GM Defense. We have a program with the Army where we launched an infantry squad vehicle, and we did it in record time. And the reason why we did that is we leveraged all of our commercial capabilities and experience and expertise. And we look to do the same here as it relates to autonomous, as it relates to electrification. So we're pretty seamless from that perspective within the company.
Great, that's great. Gary.
Jamie is asking, will the rover be EV or run on hydrogen or something else? How will it be propelled? Alan, maybe that one's for you.
Yeah, sure. The current plan is EV electrification. As I mentioned before, you can't use combustion engine vehicles on the moon. And as of right now, our plan is electrification.
That's great. What else do we have, Gary?
Marcia is asking, what's the soonest you think the rover can be ready? How many astronauts will it hold? And how far and how fast will it go? Any ideas on what it will look like? And what will it be made of? Lots of good questions there. And I think the answer is probably to be determined. Kirk, why don't you take that one?
Wow, that's a lot. So I'll probably have to talk to Marcia offline. So, so what's going to be made of? It's going to be made of very lightweight, very strong and resilient materials. So exactly what those are is still in formulation, but that's what we'll need. Of course, to actually put something on the surface of the moon takes quite a bit of effort, and we want it to be as light, as strong, and have a long life as we possibly can. So again, the range is still being worked out, but I talked before, 6,800 miles is what it takes just to go around the moon one time. We've done 3.2 before. We'd like to do somewhere between 3.2 and 6,800. So that's what we'll be shooting for. And really, the capabilities of the vehicle are still in formulation. So we spent quite a bit of time working with Jeff and Alan's team, and are making great inroads on electrification and autonomy and vehicle concepts. And our experts are leveraging all our experience in building landers and building deep space probes to come up with vehicles that will meet what we need to do. So we're looking forward to that and sharing more details as time goes on.
Getting more requirements and getting everyone's ideas into what it's going to take to make this happen on that lunar surface. Gary, what else do you have?
So Jeff and Jamie have similar questions. I'm going to combine them a little. Jeff is saying, what is the level of maturity of the rover design by the two companies that you're developing? And then Jamie kind of puts in, how much have the companies invested in the project so far? How much money do you anticipate investing?
Okay. Alan, Kirk, Jeff, Lisa, who wants to take that one? I heard 27 billion from Jeff earlier, so that's a significant
less than that. It's less than that number. I'll go first, Kirk. Maybe you can jump in. We're very much in the early stages of shaping this. I think we understand what our strategic intentions are. We know the outcome that we want. A lot of details between here and there, but I think we have a head start in terms of the experience the two companies have, and ongoing dialogues and things. But we're very much in the early stage of the program and the program details.
Sure, and the investment that we're making, we've already made. Of course, we're spending a lot of time, both from our engineers and from our designers, coming up with concept and talking about the technologies we want to include. We're looking at not only the requirements we anticipate from NASA, but from other areas we think we can, other areas of the lunar economy that we think we can satisfy with rovers. So, but we're spending a lot of time and effort in doing that right now. We actually have done a ton of engineering. The really hard part is to get engineers to converge. They really want to dream big, and so we're in the process of dreaming big and converging to what we think the requirement set will be. It's a really fun time of a project, and we're having a great time doing it, and very excited about what we're doing.
Getting that digital whiteboard and everyone throws all those ideas up there and then start scratching them out, right?
and feeding off of one another too.
Yes, that's the beautiful part about that, is that synergy when you get these diverse, a car maker and a rocket maker coming together and having people that have done things in the car space that are now thinking about another different space is really, really powerful.
Yeah, and I just to that point, go back to the beginning when Jim and Mary spoke, and we've all had the benefit of being in meetings with Jim and Mary to talk about this opportunity. I mean, we're both companies that have this long legacy of doing meaningful things for the world that just so happen to fit together like a glove, frankly, or fit together like a puzzle in terms of actually bringing our capabilities together to do something meaningful. And, we're going to do what it takes. And Jim and Mary are all in on that.
Alan, I think you said the world, but I think we need to start thinking in the universe, because we're impacting.
But you've been there. I haven't been there yet. So.
Lisa, go ahead. You had something?
I would just add, I was going to add to what Alan just said. I think, beyond the technologies that we've made investments in, both of our companies have made investments in, it's even technologies for how we're going to develop these systems, whether that's in digital transformation, AR technologies, the digital twin technologies. I think both companies are looking very hard and making significant investments in how we automate our production and manufacturing. And that's all something that we'll continue to use in this program as well, beyond the technologies that'll actually be a part of the rovers.
And that could be a whole new industry that's spun out of this, just working together as a team. Absolutely.
And when you're visiting us this week, you might actually get a ride in the Hummer as well. So we can.
I didn't get the invitation.
We don't want to go that fast yet, Leland.
Gary, what else do we have?
A couple more before we wrap it up. Eric wants to know how far along is this partnership? I'll rephrase it to say, how long has these two companies been partnering and working together? And have we ever worked together before?
Lisa, you want to start with that one?
Yeah, I think, and I'll let Alan correct me if I'm wrong, I don't think that we've had a partnership in this area in the past. So this is our first partnership in space. But, we've been working together for a good portion of a year now, conceptually talking about the partnership and how we would design this mobility system for the future. And, we exchanging ideas and our teams working together. And Leland, I think you said it, it's really the diversity of these two industries coming together has sparked innovation and excitement and the imagination of our engineering workforce on both sides. And I just can't wait to see how this continues to evolve. What I've seen so far is really, really exciting. And I think it's going to have a huge impact on our lunar mobility on the surface, the lunar economy, as well as the Artemis program. And we're just getting started, though.
Yeah, and I would just add to that this is one of several initiatives that we are working on together. So stay tuned to hear more about the others. So it goes beyond this program.
Fantastic.
Yeah, maybe if I could, one other thought is as I watch our two teams work together, it's first of all been an amazing collaboration. But the similarities and the differences between aerospace and automotive is a big part of this, right? Because as the global economy kind of moves forward, we find this aerospace and automotive relationship has lots of potential applications. So we started with this rover opportunity, but we're finding that there's lots of other paths that we can go down. It's not just the what and which markets, but the how we do it, everything from how we design, how we test, manufacturing applications. So huge amount of learning going on that I think will lead to a lot of opportunities beyond this really exciting one that's right in front of us.
I'm excited to see the rover, but I'm also excited to see the spinoffs that come out of this. Like we have a book at NASA called NASA Spinoffs, that things that have impacted our people on our planet, and how, these tangential things came out of these conversations around getting to the moon, but it helps someone here on planet Earth. So looking forward to that. Gary, do we have a couple more questions?
Just a couple more. Jamie says to follow up on an earlier question, do you anticipate the rover carrying more than 2 astronauts? How many will be capable of carrying?
I know that it just needs to carry me at some point, but at least one. But I'm gonna let you guys answer that.
Yeah, we think initially 2. You know, one is too few, and more than 2 might be too many initially. But we're going to look. We certainly would want to be able to evolve to carry as many people as we're going to have down there and need to move around. So that's the key of what we're talking about: is how do we leverage the investment we make to go meet not only the current demands but future demands. So I look forward to having a, I don't know, think of it as a pickup truck on the moon where we can pile as many people in the back as you want. So and I'm counting on Leland, you and I being 2 of those people they'll pile in the back.
I'm with you on that one. All right, Gary.
Denise is asking, what kind of timeline do you envision for this project? And are you exploring other options beyond NASA's Artemis program, such as opportunities in the commercial space? Probably a good one for Lisa.
Yeah, I mean, as we look at what's happening on the lunar surface, and I'll even talk about the Commercial Lunar Payload Services Program, or CLPS, that we're a part of for NASA, we're seeing a lot of interest in the commercial industry in getting payloads to the surface and doing things on the surface of the moon. And so when we look at mobility, we see that as a critical element for NASA and the Artemis program, but also for commercial industry and for commercial economy on the lunar surface. So we do see this as broader than just the Artemis program as a partnership here, but we're also thinking further out. And to Kurt's point earlier, having that agility in our design and the capability that we have here, I envision this to evolve over time to meet the needs of what's required from a mobility on the surface.
How many more questions, Gary? I think we have time for maybe 1 or 2 more.
Yeah, we've got quite a few. I'm going to just say 2 more.
Okay.
Joe's asking, what other areas beside lunar exploration could Lockheed Martin and GM explore? Jeff, maybe this is one for you.
Yeah, I mean, there are a number actually that we're now looking at together. It started here, but for example, you take what we do with electrification, our battery electric capabilities, but also the application for those batteries. And you find that Lockheed Martin has a lot of, let's say, electrification interests across their very broad portfolio in aerospace and defense. And so, that's one example of an ongoing dialogue. I mentioned manufacturing before. When you look at advanced manufacturing, additive manufacturing, of course, automotive and aerospace are very different. But again, the methods and the know-how and systems technology process. So there's different types of collaboration. Some are pointed towards specific applications. Others are kind of how we do what we do and sharing lessons learned on that. And there are a few others that are underway. So I think we've probably got 4 or 5 right now, but I could see that growing beyond that, and that would span automotive, aerospace, defense, and even other markets that we're both beginning to explore together.
Fantastic.
Last question here. Marcia's asking, how do you envision this lunar rover to compare with the lunar cruiser and work by Toyota and the Japanese Space Agency? Is there room for both models? Kirk, that's probably the best one for you.
Sure. I think, I have to say, I don't know a great number of details about what the Japanese Space Agency and Toyota are working together. But my understanding is a pressurized human rover. So what we're talking about here initially is mobility unpressurized. So it's quite a bit different. You can imagine needing a suite of capabilities on the lunar surface. So ours would be kind of the first thing. In fact, it could even precede the humans, but it would be there ultimately doing something more that a pressurized vehicle like Japan's talking about would be heavier, larger, and would be something that would follow on later. So I think there's room for all these capabilities. I think there's demand for all these capabilities, and we're very excited about meeting those demands.
Wow, the Artemis generation, and we are all in. I wish we could talk about this all day long. It's just such an exciting announcement. And I think there are going to be a lot of kids out there thinking about them driving the rover on the moon, or maybe they're going to be going to Mars one day. And I learned a lot myself. I have to tell you, I'm really excited about the future of NASA's Artemis program and getting our Artemis generation to the surface of the moon, and this time to stay. I sure wish I could be one of those rover astronauts. I might stow away at some point and get up there. But Lisa, Alan, Kirk, and Jeff, I want to thank you so much for your candid answers and your enthusiasm in kicking off this incredible partnership. And I want to thank our audience members for watching and participating. You had great, great questions. I hope you learned a lot today too. And I'd like to remind you to take some time tonight and look up at the supermoon and think about the first woman and the first person of color sitting in a cool new lunar rover and looking back at us here on planet Earth. For Lockheed Martin and General Motors, I'm Leland Melvin. Thank you and goodbye.